So, yesterday we were introduced to radians. What is a radian? It's a way to measure an angle. Now, why do we also use radians if we already have degrees? Well, it seems like a lot of things in our life have more than one way to measure, right? If I ask you, Stephen, how tall are you? 6'1". 6'1". Lyle, how tall are you? Wow, he is way taller than you. You're only 6 and he's 162. So we got midgets and giants in this class as a result. Well, it all matters what kind of units we're using. Right? You were using feet and inches. You were using centimeters. So all of a sudden we're using different units. It means different things. So radians are just another way of measuring angles. We already know what degrees are. What is a radian? A radian is whenever the arc along the outside of the circle, so whenever this arc right here is equal in length to the radius of that circle, so that blue line there is equal to this line, what we have here is 1 radian. So a radian is a relationship between a circle's radius and its angle. And it doesn't matter how big or how small you make a circle. So if I draw a smaller circle here, I draw its radius, I take a piece of string and I cut it out exactly that length and bend it along the edge of the circle, what I will have here is 1 radian. So if we measured this and this looks like it's about 3 inches and I went 3 inches along the edge, then the measure of that angle would be 1 radian. So how do we figure out how many radians there are in a whole circle? Well, we use the idea of circumference. If we look at a circle, and again, we took our radius and cut out pieces of string that were the length of our radius, we would find out that one piece of string would get us to there, another piece would get us to there, another piece would get us to there. And 1, 2, 3, 4, 5, 6 pieces of strings would not be enough to go all the way around the circle, but if you take out your 7th piece of string, you would have too much. So it's somewhere between 6 and 7. It's going to be, as a decimal, 6.28. As an exact number, it's 2 pi. Now you have your circumference formula from before, and all our circumference formula is telling us that there are 2 pi radiuses around any circle. So if it's 3, this length of 3 would happen once there, another 3 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 there, and then a little bit more. But every time we go 3 along the edge, we're counting 1 radian. So this will count 1, 2, 3, 4, 5, 6 and a bit radians for the circle. So because of that relationship, we find out that there are 2 pi radians in a circle. Now, one of the things that gets confusing for students is we start to write the following out. We write 2 pi equals 360 degrees. Okay? What I just did right now is I made a little mistake. I didn't say 2 pi radians was equal to 360 degrees. And part of what makes radians difficult is where degrees has a symbol, so that when you see this, you say 360 degrees. Radians doesn't have a symbol. So when we want to write 2 pi radians, we just have to write 2 pi. And we use the context of the question the question is talking about angles, then that tells us that it's 2 pi radians. But we don't actually have to write any symbol for radians. I've seen some teachers make up symbols. Let's use a degree sign with an R inside. That way the students remember that that's radians. And the reason that's important is because it becomes a misconception and students start to say pi is equal to 180. That's not true. It's true if we say pi radians is equal to 180 degrees, but it's not true that pi is equal to 180. Pi is equal to 3.14, approximately. I don't want to say all the decimal places. We'll be here forever. But that doesn't change. So it's not all of a sudden like, oh, I'm in grade 12 now. Now pi is 180. That's not true. Pi radians is 180. Just like if I said, is 100 equal to 1? Well, what happens if I said, is 100 cents equal to $1? Then the answer is yes. Is 12 equal to 1? No, but if 12 inches is 1 foot, then the answer is yes. So 180 does not equal pi, but 180 degrees equals pi radians. And so you might even want, as you start actually writing out the word radians, as you write things down, so that you're always thinking that pi radians is equal to 180. But this is further complicated when we start doing things like change 7 pi over 6 radians to degrees. So if we want to change 7 pi over 6 radians to degrees, well, we've learned already one way to do it, and then we've learned a shortcut. Okay? The way that we started off to begin with is we said, well, if I know that 2 pi radians is equal to 360 degrees, then I can figure out that 1, and I'm going to write the word here just so that we think about 1 radian, if I divide both sides by 2 pi, that 1 radian is equal to 360 degrees divided by 2 pi. And then from that, if I multiply both sides by 7 pi over 6, I'll get that 7 pi over 6 radians is equal to 7 pi over 6 times 360 divided by 2 pi degrees. And if we simplify this, you'll see that your pi's will go away. 360 divided by 2 is 180. 180 divided by 6 is 30. 30 times 7 is 210 degrees. So that's using the steps. You can always start with a whole circle. And some people like to start with half a circle as a starting point. From there, you can find out what either 1 radian is by dividing both sides by pi, or you could find out what 1 degree is by dividing both sides by 180. And then from that, you could figure out any measure of radians or any measure of degrees and convert back and forth. Now, I showed you yesterday with converting from radians to degrees that a shortcut that we often use when converting with radians to degrees, if there's a pi, since pi radians is 180 degrees, we can just change the pi to 180. This works if you have 1 pi in your equation. So now, what's going to happen? 180 divided by 6 is 30 times 7. We still get 210 degrees. It was just a little bit quicker than it was before. So the idea of a radian, it's a new measurement for angles. But we have to be careful because pi is still 3.14 as an approximation. So we can say that 3.14 radians is equal to 180 degrees. And if you did a circle here and split it into 4, and you did it in degrees, standard angle would start at 0. What angle would we have up here at the top? 90. Then, and finally, all the way around would be 360. We're going to do this in radians twice. Once using pi and once using numbers. 0 pi. All the way around, instead of 360, I could say 2 pi. Okay? Halfway around, up here, and down here, 3 pi over 2. Okay? Those are using values. So this means that pi radians is the same as 180 degrees. If I use decimals, what could I also put for all the way around the circle as an approximation? 6.28. What could I put over here? 3.14. What about here? 3.1, well, is a number. 1.57. Good. What about down here? 4.71. Good. So now that is a little bit harder to sort of imagine. Okay? If someone tells you, right, they were skiing and they just did a 270 and broke their leg, that kind of makes sense because they would be turning and ending sideways, and then they would probably fall and break their leg, right? Nobody goes skiing, oh, I just did a 4.71 radian, right? Because everybody else would look at them and say, that makes no sense, but it's all contextual. And as we get into higher level mathematics, we start to find that using radian measures instead of degrees is easier to work with. So this is part of the reason that we're going towards this and setting you up for later on in university and higher level mathematics. All right.